All right, good morning, everyone. My name is Dr. Kim Martini. I'm a senior oceanographer here at Seabird, and I'd like to welcome you to the second class of our 2021 online Seabird University. So we're just giving people a couple minutes to log on in case they got the link, make sure they can get on and everything works with the link. Thank you all for coming here today. So today we'll be going over the SBE 55. It's a water sampler, so that can be used in a variety of ways, and Greg's going to go over that today. And so I give everyone another minute so we can get all online. Some of you might have noticed that the link that went out in the email might have been missing HTTP at the beginning. So if that, hopefully your web browser connected that, but if somebody's having a hard time connecting, that could be a possible cause. So you want to give them a heads up on that. We just found out from that. Okay, I'll start now. So welcome to Seabird University. We're just going to kind of go over a little bit on the format on how we're using this. So this is virtual Seabird University. So we're using a little bit of a different platform here. This is called Teams Live. You can see us, but we can't see you. But it is interactive, so you can ask questions. You can ask them in the Q&A in the chat. And it also have the capability that you can need closed captioning, so you can turn them on in the settings, and I will show you how to do that in the next slide. So in the upper right-hand corner of your window, you'll see that there's a couple of options right there. One of them, it looks like a little Q&A bubble, two little speech bubbles with a question mark. So you can click there to ask questions and they will come into the queue. And then you can also see if you want to turn on closed captioning, you can go to the little gear and turn it on in there. So that's helpful for a lot of things as well. So as I said, we're on day 2 of Seabird University. Last Tuesday, Greg talked about profiling with and without a winch, so the 19 plus. And today we're going to be talking about capturing water on small boats, the SBE 55. So this is a water sampler. So Greg's got a nice demonstrations for you today. We're going to take a pause after this week, and in 2 weeks we're going to come back, and I will be teaching a section on moored instruments. So the SBE 37, also known as the microcat. So those are little moored CTDs. And then on that Thursday, I'll be teaching nitrate monitoring for Suna mooring users. So this is for using the Suna in a moored application. Next slide, please. What does the class look like? It's 1 hour plus 30 minutes-ish for Q&A and review. Sometimes we run a little bit over because people have a lot of questions and we can usually ask them. If you do have questions during the class, please ask. I'll be monitoring the chat as well. And I can also leverage people from Seabird using our settings as well. If you do have additional questions, you can contact the experts at Seabird Tech Support Team. I put the link down below. It's on the Seabird website. We have a great bunch of people that actually have a lot of knowledge because they deal with these kind of things every day. And so they have a lot of great hands-on knowledge to do that. And if you want to watch it again, yes, you can. We're going to be posting these recorded sessions at the end of October, so you can view them whenever you'd like and kind of review the material as well. Okay, so I just want to introduce, I kind of gave myself a brief introduction. I'm Dr. Kim Martini. I'm a senior oceanographer here at Seabird Scientific. I've been here for over 5 years. I've been using our products for over 17 years. So even before I was doing it, I was an oceanographer at various places, including the University of Washington and NOAA. And I've spent over 100 days at sea. So I did a lot of work with any moored and shipboard. Kind of just a question we have as an icebreaker is, what aspect of the ocean scares you? Most people at Seabird know that I do not like horseshoe crabs. I think it's just a relic of growing up on the East Coast and being afraid of them when I was 5 years old. So they like to give me all sorts of things with horseshoe crabs at work. So, but I'm going to pass it off to my awesome coworker, Greg, and he'll be introducing himself.
Thanks, Kim. Hi, everybody. My name is Greg Ikeda. I will be your instructor for today. So I've been at Seabird Scientific for over 6 years now. I started off in the technical support team where I was kind of run through the gauntlet of trying to figure out how all this stuff works. So I have a lot of experience when it comes to understanding how the instruments work, teaching people how to use them, and troubleshooting them as well. Prior to my life at Seabird, I've logged over 150 days at sea and spent a lot of time working with CTDs in general. At Seabird, I am the Senior Content Development Manager on the marketing team, making marketing content that we hope is helpful for you. Instead of just trying to promote our products, we want to be giving something back to the scientific community. If any of you are interested in working with us for a case study or want to showcase your data, we are more than interested in working with you. So please reach out if you can. The aspect of the ocean that scares me most is big waves. You know, sharks, all those things I think are pretty cool, but big waves just are terrifying to me. So that's me. Okay. So today we're going to be talking about this instrument called the SBE 55. This is the one that I have right here in front of me. The SBE 55 is a compact water sampler that is able to be used for real-time water sampling and data collection, and also has built-in auto-fire capabilities. That is to say that if you don't have a setup that allows you to transmit data in real time through, say, 10,000 meters of sea cable, you can still utilize the SBE 55 to fire bottles autonomously with pre-programmed settings. It can be used with and without a CTD. You can program it to fire bottles based on elapsed time with a countdown timer, or it can be used with an SBE 33, which I have right here, for real-time operation. When you do it like this, it's very similar to a system you may have seen where you're using the SBE 32 water sampler, the much larger one we offer from Seabird, and maybe something like the 9+ CTD, the bigger kind of high-end research CTD we have at Seabird. The 55 is using the same bottle firing technology as the SBE 32. These are magnetically actuated switches to fire bottles. A very reliable system that does not have any moving parts that prevents it from getting gummed up during the deployment. So I really like the SBE 55. I think it's a great optimization of the SBE 32 in a much smaller and flexible package. So there's a bunch of different parts when it comes to the SBE 55. We've got it right here. The biggest part is obviously the cage where everything is attached to. This cage here is the big metal thing. You've got your bottles, which we'll talk about later. In this case, I have a 6-bottle system. You can also have a 3-bottle system, as shown on the picture here. You have your latch assemblies. These are what you use to fire your bottles in real time. And then there's also this thing called the electronics control module. This is the brains of the SBE 55. It's what controls the latch assemblies, what handles data from the CTD, and what is handling data and power to your deck unit if you're using it in real time. It's also what's handling auto fire capabilities, commanding the latches to fire based on your pre-programmed intervals. Optionally, you can also integrate a CTD with the system to have real-time CTD data and also align CTD data with the bottles that you're firing autonomously if you're using it in that configuration. So looking at the cage, we have this open cage structure that really helps to minimize drag. As with the SBE 32, when you're sampling water, you always want to make sure that your profiling system is not affecting the samples. It's not causing a shed wake that's maybe pulling water up from the depth or disturbing any of your parameters. And then so we've designed this cage to try to be as open as possible while also having the flexibility to integrate multiple different sensors, systems, and have space for the bottles, latches, and electronics control module and the CTD. Because this is a compact water sampler, we are able to use 3 or 6 bottles where each of these bottles has a maximum size of 4 liters. So depending on your application, the amount of water you can collect with the 55 might not necessarily be enough. That being said, 6 4-liter bottles is quite a bit of water, and again, depending on your application, this could be perfect for what you need. When everything is empty, it weighs approximately 60 kilograms, about 133 pounds. With the CTD and 6 bottles, obviously when those 6 bottles are full, that weight is going to increase. So taking a look at the latch assemblies, the system can have up to two of these 3 latch assemblies. So we've got them here in this picture. I'm going to switch my camera over so we can get a closer look at the latch assemblies I have installed on this unit. Okay, so this is kind of zooming in on the physical latch assemblies we have here. In this case, we have a 3 latch assemblies, so 6 latches in total to support the 6 bottles that we have installed on this system. And now I've got one of these latch assemblies taken off of the system right here. And for those of you that are familiar with the SBE 32, the larger water sampler we have at Seabird, this might look a little bit different, but when you take the latches out, it's going to look pretty familiar. So similar to the SBE 32, these are magnetically actuated bottle firing mechanisms, where you have an electromagnet right here that is triggering the latch to release based on a signal that's coming from your system. These latch assemblies, as I've pulled out here, can be completely swapped out. So if you have a spare 3 latch assembly and you seem to be having problems with one of them, you can easily swap out the latch assembly you have installed on your system and put in a brand new one. On top of that, individual latches can be taken out. So that's actually very easy to do. I'm actually going to switch my camera over here. So we are looking. So everyone gets a better look here. So this is the latch assembly, in case you don't want to look at that tiny little window. And so individual latches can be easily removed by loosening the 2 hex screws here. And then pulling it straight out. So if you're familiar with the SBE 32, these latches are probably pretty familiar. They are in a different orientation. The SBE 32 normally has them upright like this. 55 has them tilted 90 degrees. But it's a very similar thing where you have your latch assembly that when it releases, you have this arm that swings that allows the bottle lanyard to be released, and then your Niskin bottle is going to catch the water inside. These latches can be easily swapped out. So say I'm having a problem with latch number 1. A good troubleshooting method is to say, take out latch number 1 that is having the problem and swap it out with, say, latch number 2 or 3. See if the problem moves with the latch that you just took out, or if the problem is always stuck in this position right here. That's a really quick and easy way. I would also recommend having a few spare latches on hand on your research vessel. In the event that one of them gets damaged, again, you can easily swap them out here. Something to note about these guys is that they are water lubricated. So do not put any kind of lubricant on this. Please do not put WD-40 on this thing. These, once they're immersed in water, they're going to be lubricated and they will fire reliably as long as your system is properly rigged up. Interesting factoid, these individual latches are dishwasher safe. So if you seem to be having problems with your latches, what you can do is pull all of these out of the 55's latch assembly, pop them into a dishwasher, run it on a light cycle, and then put them back in and see if any problems go away. So really, really neat design here. I'm a big fan of these latches. The predecessor to these kind of water samplers had something like a robotic arm that would go through and press buttons. And that, had a lot of moving parts. So these latch assemblies were definitely a nice improvement over water samplers for oceanography. Okay, I'm going to switch back. Okay, beyond the latch assemblies, we have what's called the electronics control module. So looking at our system, this is the white cylinder that we see here. Maybe kind of hard to see in the camera. It looks a lot like a Seabird CTD. It's about the same size and shape as the 19 plus V2 CTD. However, this is just the control module. It doesn't have any sensors built into it. So you can easily differentiate this from your CTD by noticing that the SBE 55 control module, the ECM as we call it, electronics control module, does not have a conductivity cell guard because it doesn't have a conductivity cell to guard. On the right side of this diagram, we have the connector diagram of the 55's ECM. And if you take a look at each of these connectors, you can see what the 55 ECM can support. So first, we have the data I/O connector for communication with your 55 or your CTD. Now, I say 55 or CTD because through the electronics control module, you're able to either talk to the 55 or talk to your CTD through your 55. You don't have to unplug your CTD from the ECM and plug it into your computer. You can easily switch back and forth. I'll demonstrate that momentarily. We also have our connector for CTD communication. So this is going to plug into the standard data I/O port on your CTD, the same spot that you would plug in a serial cable to upload your data or change settings on your CTD. At the very top, we have a C cable connector. This is the 2-pin connector for real-time operation with the DEC units. This C cable connector is where the 55 is able to handle the 150 volts coming from your DEC unit and is able to convert your RS-232 CTD data into DPSK communication to be handled by your SBE 33 DEC unit. I'll also demonstrate that momentarily. And then also you can see at the very bottom, we have 2 connectors for the latch assemblies. On the right side is latch array 1, which is handling latches 1, 2, and 3. And on the left side, you have latch array 2, which is handling latches 4, 5, and 6. As I mentioned before, you can have a maximum of 6 bottles to go with your SBE 55. But you also have the option of deploying only 3 bottles in the event that you don't need as much water, weight is an issue, or you only have 1 latch assembly available to you. You can run this with just 3. You don't always have to run it with 6. Now, something I want to point out is that the data I/O cable that you use for the SBE 55 is physically identical to a standard CTD data I/O cable, but is different. So looking here, we have our standard CTD data I/O cable. This is what you would use to talk to, say, a 19 plus V2 CTD, plugging it into your computer to upload data. And if you look at the pin diagram at the bottom here, this little table, you'll see that pin number 4 is null. It's not connecting to the DB9 connector that plugs into your computer. The cable used for the SBE 55 does have a wire there. So pin number 4 is connecting to pin number 4 on the DB9 connector. This is known as the data terminal ready, the DTR line. And it's important to have this pin available to allow you to talk to your 55 and your CTD. This DTR line is what provides the logic to switch between communicating with your 55 and your CTD. Again, I'll demonstrate that in the software shortly. So point is, if you find a cable that fits onto your data I/O connector here, just because it fits, just because it looks correct, and just because it has a DB9 connector that plugs into your computer, does not necessarily mean that you have the right cable. So always make sure that you've got the correct cable plugged into your 55. If you find that you're unable to communicate with your CTD or unable to communicate with your 55, chances are you're using the incorrect cable, and it's kind of hard to tell because they physically look similar. So I would recommend labeling your cables as much as possible. Now, I also mentioned that the 55 has the ability to be used in real time with an SBE 33 DEC unit and a C cable. The SBE 33, I've got one right here. Let me switch my camera over. Is the DEC unit used for handling firing bottles on a 55 or optionally an SBE 33. It's similar to the 11 plus deck unit that's used with the larger 9 plus CTD system. And so you can think of the 33 as maybe a lighter version of the 11 plus that's more compatible with the 55 and can be used with a smaller CTD like the 19 plus V2. For the sake of this exercise, this SBE 33 is the only deck unit you can use with the 55, and you require this system in order to really get proper real-time communication from the SBE 55. When you're using this, you need to have a winch, a slip ring, and a C cable to be getting that real-time data. And when you're using it, it provides power and communications to the CTD and the 55. Again, I'll demonstrate this shortly. Okay, so there's a few different ways that you can deploy the 55. One is with autonomous deployment. As I mentioned before, it can be deployed with and without a CTD. When you're deploying it without a CTD, just as a water sampler, you would program it to fire bottles based on a pre-programmed countdown timer. So, and we'll be trying this out as a demonstration in a little bit. But basically what you would do is within the software, you would tell it, I want you to fire a bottle 10 minutes after I configure it to start the profile, 11 minutes and 25 minutes after. The 55 is automatically going to start a countdown timer and then fire bottles based on the timings that you've programmed into it. Now, when you're deploying it with a CTD, you have more options for autonomous deployments. You can fire bottles on the upcast or the downcast based on pressure data that's coming from the CTD. You can fire bottles when held stationary, again, based on pressure data that's coming from the CTD. When the CTD is telling the 55, I've been held at this pressure for, say, 5 minutes, that will trigger logic to fire a bottle. And then as with deploying without a CTD, you can still fire it with a pre-programmed countdown timer, but it's also going to collect CTD data in its bottle file whenever it fires a bottle. Again, we'll see that shortly. Now, for real-time deployment, as mentioned before, you're going to use the SBE 33 deck unit, a slip ring, a winch, a C cable connected to your 55, with your CTD connected to your 55. So you require a little more equipment here, but this gives you a lot more capabilities. Your deck unit can handle input from a surface power sensor. It can incorporate GPS data from an NMEA device into your CTD data file. And then also it allows you to control when your bottles are fired. So you'll be getting real-time data from your CTD. So you can see, okay, we're looking at the chlorophyll max. We want to fire a bottle here. Here's the halocline, here's the thermocline. You can really pick when to fire your bottles based on the CTD data that you're getting in real time. So this really gives you a lot of capabilities, and in many ways, this replicates the same kind of science you can do with a larger 9 plus package that's using the 11 plus deck unit and the, say, 24 carousel or 24 bottle carousel on an SBE 32. This is kind of just a miniature version of that that's more compact and a little more self-contained. So if you don't need to be hauling a large SBE 32, this package is perfect for that. It works really well. So you can fire bottles from the software within CSave, or you can also use the physical button on the front of the deck unit. And depending on how you have it wired up, you can do a lot of stuff with the data you're getting from CSave based on when the bottles are fired. We'll see that momentarily. Finally, we have the ability to post-process that bottle data. So within SBE data processing, depending on how your bottle data was collected, whether you're getting it in real time from CSave as a .bl file or from autonomous deployment as a .afm file, you can take that data in the data conversion module and produce a .ros file that can then be passed to the bottle summary module from within Seabird data processing, which is going to give you a convenient file that has a summary of all the CTD data that's surrounding the moment that a bottle was fired. For example, it'll give you the bottle position, serial number, and date and time, and then data that you select to be associated with that bottle. This is handy if you're doing something like checking to make sure that your CTD salinity data matches up with data from an autosal. You can do a cast, fire your bottles, process your data, and get a bottle summary file to look at the salinity data from your CTD that's surrounding, say, bottles number 1, 2, and 3. From bottles number 1, 2, and 3, you might take a salinity sample, run that on an autosal, and compare that to your CTD data. You can do similar stuff with oxygen data, running a Winkler titration to make sure that your CTD oxygen sensor is working properly, or if you need to do some field calibrations. So this gives you a lot of useful capabilities for comparing your CTD data to bottle data, or even maybe taking something that you can't sample with your CTD and comparing it to other parameters that were measured by your CTD. Okay, so that's all we have for the PowerPoint presentation. Now I would like to get into some demonstrations of the software. So let's. So the software that we're going to use with this system is called CTerm AF V2. This is very similar to standard CTerm with some added tools for configuring and setting up your SBE 55 water sampler. This software also works with the AFM, the auto fire module that's used with the SBE 32, and gives us a lot of options here. So let me just get set up here, switch the camera over. Okay, so on screen, I have CTerm AF V2, the software right here. And the first thing we're going to want to do is configure the software based on the system that we're using. So you can see here, there's a lot of options based on the instruments you're using. In this case, I'm using the SBE 55 Eco water sampler with an SBE 19 plus V2 CTD. You can use the this water sampler with different CTDs like the 25 plus, an older version of the 19, older version of the 25, and also without a CTD. In this case, we do have a CTD, so we're going to configure it like this. So your setup file is based on everything you have set up in this menu. So that's a pretty standard .psa file format that we use for a lot of the Seabird software. And what's really important is we go to this communication setup phase where we're specifying the serial port that we're communicating with our 55 and the baud rates we're using to communicate with our CTD. So first thing we want to do is configure the right serial port to communicate with our 55. So right now, I have my SBE 55 plugged into COM5 on my computer. So I'm setting that up as COM5. 55 will always communicate at 4800 bauds with 7 data bits even parity. And here I need to specify the communications between the CTD and the computer through the SBE 55. So what this really is because my CTD is plugged into the 55 and the 55 is plugged into COM port 5, I don't need to specify a COM port here. But what I do need to specify is the baud rate of my CTD. So currently my 19 plus V2 is configured to communicate at 4800 baud. If I were to plug this 19 plus V2 directly into my computer, I would need to configure CTerm to talk to this at 4800 baud. And so I'm going to pick 4800 here. If this is incorrect, you will not be able to properly talk to your CTD through your 55. So make sure that this baud rate is correct. Now, the default baud rate for most CTDs without water samplers is 9600 baud. In order to use it with an SBE 33 deck unit in real time, it's required to be at 4800 baud. So I've pre-configured my CTD to be at 4800. And so that's why it's like this here. Okay, so I'm going to click OK here and connect my water sampler. So once it's connected, you'll get the A prompt here. And when you see that, you know that you are connected to your SBE 55. If you have your CTD properly connected to your 55 and the baud rate is correct in that configuration window we just went through, when you click on this Connect CTD button, it's going to switch over to communicating with your CTD. So now I can talk to my CTD, change setting as I want, see the current settings of the instrument, and even upload data through the 55 in the C-term AF software. Personally, if I'm going to upload CTD data, I like to connect my CTD directly to my computer and upload it through there. But you do have the option of doing it through here. I just like doing things with a little more of a direct connection. That being said, it is convenient that you can switch between your CTD and your SBE 55. Now, recall that I had shown those two cable diagrams and specified that you have to use a specific cable when working with your SBE 55. If you're not using the cable that has that pin 4 that's connecting to the DTR line, you won't be able to do this switching procedure. It will be stuck on either just the CTD or just the 55. In this case, I'm using the correct cable, so I'm able to switch back and forth between the two. Okay, so with the 55, there's a pretty limited set of commands that it responds to, one of which is the standard DS command, display status. And that's just going to tell us, hey, this is my 55 serial number, this is the current battery voltage, and my system is not armed at the moment. Armed means that the system is ready to fire bottles based on your autonomous pre-programmed settings. We'll see that in a moment. It also responds to the DC command, so that will display the current autonomous bottle fire settings, as well as the baud rate to communicate with the CTD, etc. So right now, my fire mode is closed on elapsed time and record CTD data. We can change that up in the settings. It also responds to the get HD command, which is just going to tell us a little bit more information about our firmware version, what software we use to upload firmware, and the date and time. Not really much more helpful than the DS command. In general, the DS command and the DC commands are really the only ones that you need to do. If you don't know those commands, we also have options up here where you can click on the status, and that's going to automatically send the DS command. Now, the 55 also has the useful option of being able to test latches. I have the camera zoomed in on the latch assembly here. Word of warning, you do not want to close these bottles in air. Doing so will cause damage to the plastic, cause damage to the seal, and you might have a leaky bottle. So I'm not going to rig these up to the latches because I don't want to damage these bottles. Instead, to demonstrate the latches, I've connected rubber bands to this system here. So then we can really see when this latch fires. This is sort of a cheap simulation of what it would be like if it were firing a bottle. So normally you don't have rubber bands on the system, but this is here for demonstration purposes. Kim and Lindsay, can you confirm that the camera is showing the latches and that's all visible?
Yes, it is.
Okay, thanks. Okay, so within C-term AF, say I just want to make sure that my latches work. Something that I'm going to do is send the command fire 1. This is going to fire latch number 1. Now, it'll take a minute for it to charge up before it can fire. So when I send that, it's going to say wait 10 seconds for capacitor to charge. In about 10 seconds, we should see that rubber band pop the latch up, and we'll hear an audible click. Okay, so I don't know if you could hear that, but hopefully you could see the rubber band pop up. That latch fired. I got a confirmation message in C-term V2, and I, in this room, heard it pretty loud. So this fire command responds to latches 1 through 6. So I'm going to say fire 2. Okay, fire 2. Okay. I seem to be having some. Maybe my mouse is not functioning. Okay, I don't exactly know what's going on here. My computer seems to be having an issue. Please stand by.
While Greg is working to resolve that technical issue, I did send a survey in the chat for everyone. It should be at the top of the published Q&A if you want to take a look at that. Basically, it's a survey. If there's anything in terms of content that you feel was missing from Seabird University this year, or just something that you'd like to see on the itinerary for next year, please feel free to give us your feedback. We're always looking to make sure that we're answering questions from customers and ensure that we are covering topics that are relevant to you. So your feedback is really helpful in making sure that we can do that. So it should take you no more than 5 minutes to fill it out. So if you guys wouldn't mind doing that, that would be super helpful for us as we plan our schedule for next year. So thanks.
Okay, thanks, Lindsay. I think I sorted this out. Problems with the touchpad here. So you may have seen that I fired bottle number 3 with the fire 3 commands. We can do the same things with latches 4, 5, and 6. Just fire 4, fire 5, fire 6. Now I'm going to go back and re-engage these latches. Now to re-engage the latches, you really have to just push them back into place. The latch mechanism should catch. If it doesn't seem like it's catching, you can pull up on this little trigger right here, and then you'll know that it's re-engaged if you're unable to pull on the latch. Very similar to the SBE 32. Let's put these rubber bands back. Okay, so that is really the overview of sending commands within this window within CTerm AF. Now, the next thing that we're going to want to do is take a look at the auto fire parameters in CTerm AF. So we're going to go back to this configure window, select SBE55 with 19 plus V2 or whatever configuration you're using. And then we already looked at communication setup. We're going to look at bottle closure logic. Now, this is where you define how the system is going to close bottles. Now, unfortunately, because I have my 55 and CTD here at atmospheric pressure of Bellevue, Washington, and I'm not doing an ocean profile, I cannot demonstrate closing on the upcast or closing on the downcast or stationary because my pressure is not changing. However, what I can demonstrate is closing on elapsed time. So let's take a look at this. You have the option to close on elapsed time, record CTD data, or close on elapsed time, do not record CTD data. This would be identical to if you're deploying the 55 without its CTD. In this case, we have one, so let's click on that. Once you've selected your bottle closure option, then you want to go to the next tab and define the bottle closure pressures or times. So if you're close on upcast, this is going to say, this is the pressure at which I want to close. When you're saying close on elapsed time, you're saying this is how long after arming the system am I going to close my bottles. So these have to be an integer value apart from each other. So it has to start at 2 minutes after arming. That's the minimum amount of time. And then the differences between each one has to be at least 1 minute. So in this case, for the demonstration, let's set it to fire 2 minutes after arming and then fire each bottle sequentially 1 minute after. Okay, so we've got that. Once I have that set up, I am going to make sure I'm connected to my auto fire module and then click on this program button. What that's going to do is whatever settings we had in that configuration window will be sent to the SBE 55, and it will automatically program my CTD to output data in the correct format used for auto fire modules. If your CTD is at output format 0 or output format 1, 2, or 3, the auto fire module won't know how to interpret the pressure data coming from it, so you won't be able to fire bottles based on the upcast or stationary, and the 55 won't know how to interpret it. So in this case, when you click on program, it will automatically program the CTD for the correct output format. Okay, so what we've done is just programmed our 55 to close bottle number 1 after 2 minutes, bottle number 2 after 3 minutes, bottle number 3 after 4 minutes. That countdown timer is going to start once I click on this ARM button or send the command ARM, ARM. Okay, so now that it's armed, we have a countdown timer here. So this is going to take 120 seconds. Keep an eye on our rubber band system over here for when this closes. So in the meantime, let's take a chance to look at other settings within CTRL. So as I mentioned before, you have your close on upcast, close on downcast, or close when stationary options. These are based on pressure data coming from your CTD. So with close on upcast, you need to define the logic that determines that the CTD profile has entered the upcast stage. You do that in this window here. First thing is the minimum pressure to determine the upcast. Because we don't want to accidentally fire bottles on the downcast, the 55 is going to say, I will not fire any bottles until I have met this minimum pressure. So say you're doing a 600 meter cast, you might want to program that to something like 500, 550 meters. This pressure needs to be a pressure that is met during your cast. So in the event that you set the minimum pressure to be 500 decibars, but you only get down to 450 decibars, your 55 is not going to fire any bottles. So make sure that this is less than your maximum depth, but close to it so that you don't accidentally trigger a bottle fire during the downcast. Next, you have your pressure decrease to determine the upcast. That is to say, once the CTD has stopped profiling or stopped the downcast, your pressure is going to decrease as it's entering the upcast stage. This is saying once the pressure has decreased by 10 decibars, then we'll enter the upcast stage. Okay, 120 seconds. Let's take a look. Okay, so that bottle just fired, and something you'll see here is it gave us a confirmation message, but it says no CTD data. If you don't start logging with your CTD, the 55 is not automatically going to tell it to do that. So I'm walking over to my 19 plus V2 and flipping the switch to on. Now I have CTD streaming into the 55's system, and it will log the CTD data, and we'll see that in the next fire message. Okay, as we're waiting for the next bottle to fire, the next thing is the bottom bottle closure enabled option. And so what this is going to do is allow you to close a bottle at the bottom of the downcast based on stationary time. So if we take a look at this, now we know that bottle number 1 has this stationary logic here. And so what we need to do, okay, bottle number 2 just fired. We got a confirmation message, and it did not say no CTD data because we successfully have CTD data streaming into the terminal. It's going to fire bottles 3, 4, 5, and 6, but we don't really need to look at those because we already know how this works. So stationary logic is based very similar to what we do if we set our bottle closure logic to close when stationary. In this case, to fire the bottom bottle based on stationary logic, we need to define an amount of time that it's going to sit on the bottom. So in this case, I'm saying when it's sitting on the bottom at 5 minutes after meeting this minimum pressure, then it's going to close bottle number 1 stationary here. Now, you might be in an environment where you have significant amounts of ship heave, and then so stationary is relative to the motion of your vessel. And so in this case, we want to define a window of what is quote unquote stationary. So in this case, I've defined 10 decibars. So after we meet this minimum pressure, as long as my CTD package is sitting here within a 10 decibar window for 5 minutes, it's going to close bottle number 1, the stationary logic. From there, we'll start the upcast. It'll rise by at least 10 decibars, and we can tell it to close bottles at, say, 400 meters, 300 meters, 250 meters, 100 meters, and 10 meters. At that point, it's going to close bottles at these points. Now, something that is typically best practice with water sampling is you want to hold your CTD package in place for at a minimum 60 seconds to allow the water in the bottle to equilibrate, to get rid of the impact of your profiler through the water. Unfortunately, because you're using autonomous bottle firing, you don't really have the option to do that here because you don't necessarily know when you're reaching these pressures without real-time feedback. In this case, I would recommend, if you can, monitoring the amount of wire out from your winch to estimate when you're reaching nearby these pressures, and then slowing down the CTD package as you're getting to these points. That is sort of the best case you can do with autonomous bottle firing. That being said, instead, you can also use the close when stationary logic. In that case, all of these are going to close when the system is held stationary, very similar to the pressure window and timing we set in the close on upcast option. So with close when stationary, you're going to program similar things. The pressure for the first bottle is the minimum pressure to determine upcast, very similar here. Minimum change between bottles is the amount of distance between each of your bottles. So say you don't want to close 2 bottles at too close of a location to each other. You can program this to be a minimum difference between each bottle. So they'll never close within 10 decibars of each other. The pressure window is the same thing as the pressure window here. And the time to hold in pressure window is the same thing as the stationary time on bottom here. Now, what you're going to do is deploy your CTD package once you reach this pressure. As long as you meet these criteria, the 55 is going to automatically close a bottle every time you're held within these windows and have met the minimum change between them. Okay, so that is really it when it comes to autonomous bottle firing. I see we've just closed our last bottle, number 6. And successfully got confirmation messages for all of these, and we're getting CTD data for everything. So that's how you configure your SBE 55 to fire bottles autonomously. Now, always remember, once you've changed these settings, you need to click on, oops, I'm getting CTD data. You need to click on the program button while you're connected to your 55. In order for it to properly be ready to be deployed. Now, so I've just programmed in that stationary logic. It's programming my CTD for the right formats. And then before you put it in the water, always make sure you re-engage these latch triggers, pushing them in, verifying that they're going to stay. Put these back on. And always, always, always arm the system. If you fail to arm the system and you put it in the water, it's not going to do anything. So when you click on arm, it'll say armed. Now when you send the DS command, it will tell you it is armed. It's ready to put in the water. Now, once the system is armed, it doesn't respond to as many commands, such as the fire 1, 2, 3 command. So what you can do to disarm it is send the DA command, disarm. And when I send DS, it'll say it is not armed. Okay, so that is collecting data autonomously. The next thing we're going to do is take a look at this SBE 33. and configure it to get some data in real time. So first thing I want to do is just communicate with my SBE33 to determine the settings that I need. So I'm going to open up CTerm v2, click on SBE33 interface, and that's going to launch CTerm 1.59, this older version of CTerm that we use to communicate with the 33. Now within CTerm version 1.59, I'm going to click on Configure SBE33 and set up my configuration options. Now I know that my 33 is connected to COM port 9, communicating at 9600 baud with 8 data bits and no parity. So I'm going to click OK. Actually, we're going to switch my camera. And now I'm going to power on my SBE33. Something I also want to do is disconnect from CTerm AF, because that is going to cause it to send some weird signals. And when you initially connect to this, due to some electrical noise, you'll often see just a bunch of garbage characters here. Ignore those, that's fine. And in this case, I am currently communicating with my CTD through my deck unit through the SBE55. So I have my deck unit plugged into the serial port, which is connected to CTerm right now. My deck unit is plugged into my SBE55 through a test C cable. And then my CTD is plugged into my SBE55 through an RS-232 cable. Despite all that convolution, I can still talk to my CTD through the SBE33 and see the current settings. Now, what's important to do here is just determine what is the current COM port and baud rate I'm using to communicate with my SBE33 and confirm that I am able to talk to my CTD. That's really all we need to do in CTerm. And now one thing I want to point out before we move on to CSave is that currently the output format says converted hex for AFM. That is going to cause a problem that we'll see momentarily, but I'm going to leave it right now so you can see what that looks like. Okay, so this is great. We've established communication with our SBE33. We know that we're able to talk to our CTD. So then we're going to move on to CSave, the real-time data acquisition software. And take a moment for that to load. Okay, so I have CSave all set up for real-time data acquisition. Now, the first thing I'm going to do is go to this configure inputs window and make sure I have the correct XMLCon configuration file loaded. If you're not familiar with XMLCon files, I talked about how to create these and edit them to be correct for use in CSave in the previous session. So take a look at the recording of that session when it becomes available. Right now, I'm opening my XMLCon file to work with the particular CTD I have connected to this unit. Next thing I'll do is go to the serial ports tab. Now, if you were here for the last session, you'll see how we set this up to communicate with the CTD. Next thing we're going to do is show how to set it up with a water sampler. So in the first window, the CTD serial port, we're setting it up to the same COM port and baud rate we used to communicate with the 33 deck unit in CTerm. So that was COM 9, 9600 baud, 8 data bits, no parity. Now, you might be a little bit confused here. I mentioned before that my CTD is currently set to 4800 baud, and that's true. That being said, we want to set the baud rate used to communicate with the deck unit. So currently this is 9600 baud. You might often find that this is set to 4800 baud. That's okay. The important thing is that this baud rate needs to match the baud rate of the deck unit. For simplicity, I'll often set everything to 4800 baud. So I'll set my 33 to 4800 baud, my 19 plus V2 to 4800 baud, and the SBE 55 is always communicating at 4800 baud. That just keeps things aligned, makes it easier to organize your settings. Okay, and then the next thing we're going to do is specify the COM port for the water sampler. Now I'm going to switch my camera back and I'll show you what this looks like on the back of the deck unit. Now, this is the back of the SBE 33 deck unit. And you'll see there's a bunch of connectors back here. Right now, I'm connected to AC power right here. And there's two serial data connectors, serial data and carousel data. This serial data connector is what we use to talk to the deck unit in order to talk to our CTD. So this is connected to COM9 at 9600 baud. This carousel data serial cable is what you use to get bottle confirmation messages coming from your SBE. You won't be able to send a bottle fire command from CSave because that travels through this carousel data connector to the 55, which sends a signal to trigger the latch assembly. So make sure that this is connected. This serial data connector needs to be connected to its own COM port. So currently I have this connected to COM port number 8. I have a little daisy chain of USB serial adapters here. COM port 5 is connected to my 55 deck unit. COM port 9 is, 55 electronics control module. COM port 9 is connected to my serial data connector on the deck unit. And COM port 8 is connected to the carousel data connector on the back of the deck unit. So in this case, for real-time data acquisition, we need two COM ports, COM port 9 for getting CTD data from the deck unit, and COM port 8 for getting data from my water sampler. Now I'm going to arrange this back here. Okay, that looks pretty good. Okay, so I've tested these already. I know that these COM ports are correct. Now I'm going to click on this water sampler tab. And if you haven't used a deck unit before, by default, this might be set to none. Once you're using the SBE 55 or say a SBE 32 or a different kind of water sampler, not from Seabird, you'll need to specify that here. So I'm going to click on SBE Eco. That's the SBE 55 Eco water sampler. I'm going to tell it how many bottles I have. So in this case, I have 6 bottles. And I'm going to pick a firing sequence. So the easiest one is sequential. That will just fire bottles in order, 1, 2, 3, 4, 5, 6. You also have user input, where you can tell it, I want to fire bottle number 3. I want to fire bottle number 2. I want to fire bottle number 6. In whichever order you pick, you need to make sure that you're keeping track of which bottles you're firing. There's table driven, where you specify a table of the order that you want to fire bottles in advance. And then there's also auto fire, where similar to CTerm AF, you can configure it to fire bottles autonomously based on pressure from your CTD. And you can also configure it to manually fire bottles from the button on the front of the deck unit or from CSave. In this case, because we have full real-time capabilities, I'm going to set it to sequential. It's a little bit simpler, a little bit more straightforward. Now, an additional option that we're not going to talk about today is if you have a remote control via TCP IP on your network, you can set this up to fire bottles remotely. In this case, we're not going to go into that now. It's a pretty advanced tool. Okay, so we have our serial port set up. CTD serial port matches what we had in CTerm. This COM port matches the COM port. I'm connected to my water sampler. My water sampler is picked correctly. My number of water bottles is correct, and my sequence is sequential. So I'm going to click OK, and we're ready to go. Now, these are my real-time displays that are going to show CTD data, and then I can also configure these to show a line in the profile whenever I fire a bottle. So in this case, I have show lines clicked and then show the sequence that's going to tell us the bottle number that was fired next to each line. And we can label the bottle position, pressure, or both. In this case, I'm just going to say bottle position, and then that line is going to be a thin, solid line. You can make it look whatever you want. Okay, now we're going to start real-time data acquisition within CSAVE. So I'm going to click on real-time data, click on start, and I want to say begin archiving data immediately, and I'll name my file that it's going to save with csave test2. Now, what this is going to do is it's going to save a .hex file containing all the CTD data that we are collecting in CSAVE from our 19 plus v2. And it's also going to save a .bl file containing data on when the bottles were fired based on the bottle confirmation messages we're getting. So there will be a file called csave test2.hex that contains CTD data, and a file called csave test2.bl containing bottle data. Click on save, and we are ready to go. If you didn't already do configure inputs here, you have the option of specifying your XML con file, your serial ports, and your water sampler. We've already done that. Now, recall that we currently have the incorrect data format going for our CTD, so we're going to see an error, but I want to show what that looks like. I'm going to click on Start. Notes is a test. Output format is currently incorrect. Okay. Okay, so we failed to initialize CTD serial port COM9, probably because I already have CTerm open. I'm going to close that, and we're going to try that again. CTerm was occupying COM9. Okay, first thing it's going to do is say launch CSAVE acquisition, and then you may have seen it briefly. It says initializing the water sampler. If you don't have the correct COM port set up for your water sampler, or you don't have a serial cable connected to the carousel data connector on the back of your deck unit, it's going to give you an error saying failed to initialize water sampler. In this case, everything is connected properly, so now it's just waiting for CTD data. Okay, I just flipped the switch to on my CTD, and so CSAVE is now collecting CTD data, but we don't see anything popping up in our displays, and we see what's called a scan length error at the top here. What's going on is because the output format is still set for what we need for auto fire, that is output format 4, that output format is not compatible with CSAVE, so we need to go and switch back. So I'm going to set my CTD to off. That's going to stop this. And real-time data, I'm going to say, is stopped. Now I'm going to relaunch CTerm. Go back to the SBE 33. Configure COM9 9600. Okay. And take a look at my CTD. So right now it says output format converted hex for AFM. In order to use CSAVE, we need output format. Format 0. That is raw hex. So if we take a sample in raw hex, that's going to look like this. Our scan, I want to say, is probably 22 characters long. However, if we use outputs format 4, our scan length is 10 characters long. And so CSAVE is expecting a scan that looks like this. In output format 4, it's getting a scan that looks like this. So it gave us a scan length error. So output format 0. And just for good measure, let's take a look and see, yep, output format is raw hex. We're ready to collect data in CSAVE. So let's close out of that and restart real-time data. We've already set all this up. Click start. Yes, we want to save over that file. This is a test. Format 0. Okay, so we've initialized the water sampler. We've started data acquisition. I'm going to flip the switch to on. And now we see some data streaming into our displays here. In the scroll display, we see what is currently room temperature, 0 conductivity because my CTD is in air, and atmospheric pressure, essentially 0 with some fluctuations based on current atmospheric pressure versus when the instrument was calibrated. In this display here, we see our CTD data. And now I want to modify my ranges so temperature goes down to. Okay, so we have temperature in green, conductivity in orange, and pressure in black. Now, imagine this is a standard CTD profile. Normally, because we have changing pressures, you might see something that has temperature, conductivity, salinity, everything going down with pressure on the y-axis. In this case, because pressure is not changing, I have it just set up to have time on the x-axis because that's the only parameter that's changing right now. Now, we have the ability to fire bottles in real time. So if we click on this real-time control button, we can click on the fire bottle control. That's going to open up this little window here because we determined that we want to use sequential bottle fire. This is going to give us the ability to fire our bottles from CSAVE. And because we specified that we want to have a line that shows the bottle position in this plot, we'll see that show up in CSAVE. So real-time control, fire bottle control. Now let's fire bottle number 1. So you may have seen, I guess my rubber band didn't actually flip upwards here, but latch number 1 has fired. This latch is loose. And we've got a line here that says bottle number 1 has been fired. Now next, bottle number 2. We just fired bottle number 2 and bottle number 3. Fired bottle number 3. And then we don't have rubber bands connected to them, but we can fire bottle number 4, bottle number 5, and bottle number 6. Okay, so that is a really condensed version of what you might do in a real-time CTD profile, where you're firing your bottles in real time. Now, if you take a look at the deck units, you also have. I'm going to just move this over. Might be a little bit blurry, but right here, this green button is the fire button. You can manually fire bottles in real time using this physical button right here. And then these lights here are showing you which bottles have been fired. So when I fired 1, 2, 3, 4, 5, 6, these bottles lit up. In the event that you don't have this carousel data serial connector connected to your computer, you can still fire bottles from the deck unit in real time with the physical button here. However, you are not going to get any bottle confirmation message in CSAVE. And then so you won't see these black lines showing up, and you won't be able to get the .bl file that we're creating from this profile. So let's stop real-time data and really quickly take a look at the files that we have just created. Okay, so this is the directory where we saved all of our files. And as we saw, we have csavetest2.hex. This is the file that contains all of the CTD data that we collected in raw hex format with any information that we put into the header right here. we have csave test2.bl. Now, this is a file that contains the bottle data based on the bottles that we fired in csave that correspond with these black lines. So this essentially just has a date timestamp and then the range of scans that are associated with that bottle when it was fired. And then we also have a header file and an XML-con file. So this is just a copy of the XML-con file that we loaded into csave, just copied with the same name as these. So what we can do is within Seabird data processing, run the data conversion step. And in the data setup tab, we can specify to create both the data and the bottle file. So what that will do is create a converted data.cnv file from our hex data, and then also a .ros file from our bottle data. And now what you need to do is select the source of scan range data. In this case, it's a bottlelog.bl file. But if we uploaded a .afm file from our SBE 55 that has similar information as the .bl file, Seabird data processing can use that as well. So in this case, .bl. And you can set an offset of scan range and then a duration for the amount of time you want of CTD data surrounding that bottle fire. Finally, we want to select our output variables. This looks good to me. Go and start process. Okay, so now I have our CNV file, and I should have a .ros file, but okay, I'm not 100% sure why I'm not getting a .ros file, but typically when you go through this process and specify create both bottle and data file, let's try this, you'll get both a CNV and a .ros file. But I don't seem to be doing that right now. Anyway, once you have that CNV file and that .ros file, you can pass that to the bottle summary module within Seabird data processing to create a more comprehensive file that contains CTD data surrounding each of your bottle fires that you can use to take a look and correlate the data you get from your bottle samples, the physical water sample that you're maybe running in the lab, with the data collected from your CTD sensors. That's good for calibration purposes. It's good for just lining up CTD data with parameters that you can't measure with sensors. And it provides just a useful record of the bottles you fired for each cast. Okay, so that's pretty much what we've got today. At this point, we can open it up for questions. Kim and Lindsay, do you have anything on deck?
Yes, it was kind of a one. Oops, let me switch my camera. So we were asked, can the SBE 55 also be used with the SBE 11 deck unit? No, it cannot. So the 11 is specifically designed for the 9+. It's just a completely different, more system that's designed for like a bigger, a bigger suite of instruments. So the one that you can use it was the SBE 33. So, and it's designed, SBE 33 is designed to make things like the 19+ or the 55 more modular. So it kind of has just a different approach to that.
Okay, so Jonathan, very astute observation here. Apparently I'm only processing one scan. So Let me try to redo this. Kim, go ahead and answer any questions while I fix my mistake.
Okay, and then there was a question about setting up the auto fire. So when can you do, so there's kind of a radio buttons and you can only pick one at a time. So can you do an upcast or a stationary or design when it's going to go choose it, and you cannot pick two buttons, so it's not that complex. But that's actually a good note to hopefully we can do something like that in the future. And so, but there is a workaround. If you know so we do always recommend taking bottles on the upcast. So you get, when you're on the downcast, you're getting nice clean data going down. The whole entire package of the CTD and all the sensors are falling through the water, and you're not getting a lot of ship heave. And then when you're on the upcast, you can take the bottle samples, and it's also because you're taking the slack out of the line that's connecting it to, so you get a lot better accuracy of where your bottle is if you don't have the direct pressure sensor on that. So how to take your bottles on just the upcast, just do it when you're stationary. Make sure you don't stop on the way down, and make sure you stop for a long time on the way up. And you also set the pressure window for a bit longer as well. So that's a workaround for that. And you can also do that too. If you do it the stationary and you kind of know when you're stopping, you can do that as well. So you can kind of, if you adjust your winch in and out accordingly, then you can do that as well. All right, and then I have Greg. There is another question from Donovan that I'm also going to punt to you because this is you. So I think you did answer it, but I think it's probably good to answer it again. So it's I assume the 19V plus V2 needs to be powered on for the cast, or does the ECM send a wake up command?
Yeah, so the 19 plus V2 needs to be logging for the cast. So in most cases, you'll use the magnetic switch to, let's see if I can pull this out, to start the profile. So essentially, data needs to be streaming from the CTD to the 55 before you start the cast. The 55 does not automatically send the start logging command. So in this case, as we saw when I was demonstrating the elapsed time, when we armed the 55, it started the countdown timer and it fired bottle number 1 and gave us the message no CTD data. That's because I did not put the switch to on. So once I flipped it to on, hex data in output format 4 was sent from the CTD to the 55. And in that case, when the next bottle's fired, we got a bottle confirmation, and we did not get that message saying no CTD data. So good question. CTD needs to be logging and outputting data before you start the autonomous cast.
All right. And do we have any more questions from people? My favorite colors are red and oranges. That's one question I can answer. Greg, is there anything else you want to cover that you thought of?
Nope, that's pretty much it for me. Jonathan, you were correct. I was only processing one scan, so now I have a .ros file. It's got some nice bottle data, CTD data in here, and I can pass that to bottle summary. Thank you for catching that. Yeah, you know, I really like the SBE 55. I really like the SBE 32. That system is probably more capable, obviously can hold more bottles. But in many cases, sometimes you just need a little bit of water, and the SBE 55, in my opinion, is more streamlined. It doesn't need as much knowledge to operate, and it's very compact. That electronic control module handles a lot of stuff for you. It gives you the ability to fire bottles autonomously. For the SBE 32, you need either the auto fire module, the AFM, and then cabling that thing to the 32 is kind of a pain. You can also use, when you're using a 9 Plus, the SBE 17 Plus, the CRAM. That's got an auto fire module that provides power and data for the 9 Plus. I really like how straightforward the SBE 55 is. And everything that I demonstrated today is essentially everything that you need to know and more for your system. One thing I didn't mention about latches, I guess, is that it's recommended to periodically just rinse these off after every cast, just rinse it off with clean, fresh water. And then also, if you're having problems, you can pull the latch assembly off of the 55 and put this into a bucket of soapy water before you remove individual latches and put them in a dishwasher. But that's the same kind of maintenance strategies you would use for the 32. And it's a great system. I'm a big fan of the 55.
Thanks, Greg. I don't see any more questions, so I'm going to say, well, thank you everyone for attending. Join us again on Tuesday, October 19th, where we're going to start covering moored sensors. So we're going to start with the microcat, and that Thursday on the 21st, we'll be covering setting up the SUNA for monitoring. So I'll be teaching those, and I'll look forward to seeing you there. Again, if you have any additional questions, please email tech support. They're extremely knowledgeable, and they've seen all sorts of they have lots of experience and have talked to people about many, many different configurations and can do a great job of helping you. So thanks very much. Anyone else? Lindsay, Greg, have anything to add?
Nope. Thanks for attending, everybody. We appreciate it.
Yeah, thank you, everyone. And if you wouldn't mind, again, I'll note that survey at the top of the chat. So if you want to fill that out, that would be awesome. But other than that, nothing from my side. Thank you, everyone.
All right. Bye.